Hey everyone, very good evening and welcome back again to this demo on FortiGate's Add2 Passive HA cluster architecture. So in the last session, we have seen the deployment of FortiGate's single NVA deployment on Azure, right? So we're just going to extend that existing architecture into an understanding of having a hub VNet and a spoke VNet and how exactly FortiGate is going to steer the traffic for both east-west as well as the north and south, right? So without any further ado, let's move forward. So just to quickly reiterate, so this is our official repository, our reference point. So this is the URL that you can follow, and you can download all your Terraform configuration file from this repository, right? And for this particular demo, we are going to discuss more about this architectural deployment, where we are going to discuss more about the hub VNet and the spoke VNet connectivity. So at a very high level, from this diagram, what you can understand here is that there is a VNet which is named as a hub VNet or inspection VNet, and there are multiple spoke VNet which are paired with the hub VNet. So these spoke VNets might be from a different region. So this might be from Central India, this might be from the North India, might be connecting to the South India, right? So all the traffic that is generating from this particular spoke VNet, let's say this is the traffic that is generating from Central India. So all the traffic will move towards the hub VNet, and all the inspection of that particular traffic will happen at the hub VNet. And this particular hub VNet or this particular FortiGate VM, it's going to take a call where to send the traffic and whether the particular traffic should be allowed or not. All the policies are enforced at the central location. So that is why we call this VNet as the inspection VNet, right? So be it a east-west traffic or be it a north-south traffic, so everything is going to be inspected and steered by this particular FortiGate active and passive VM, right? So just for the understanding of this hub VNet area, so we are going to have a two VMs. One is active and another one is going to be in passive, right? And there is going to be a public subnet sitting in address zone, and there is a private subnet which is sitting in trust zone, right? And similarly, we are going to have a dedicated management port in each FortiGate VM, so indicated by the green arrows. And similarly, we are going to have a HA sync subnet, so which will help you to keep the HA sync between these two FortiGates. So there is a dedicated port 4 we are going to make use of for this particular FortiGate and this FortiGate, right? So as an overall, as you can see, for a particular the FortiGate VM, there will be 4 private IP addresses, right? So there will be 4 network interfaces which we are going to create as part of this Terraform deployment. So considering this architecture, so this particular VM1 carries 4 NIC, and this particular VM2 carries another 4 NIC, right? And the private IP address what we have assigned to that NIC are listed here. So for the port 2 of the active, we have assigned 0.10, and the port 2 of passive we have assigned 0.11. So similarly, we have assigned individual IP address from this subnet pool from the each subnet pool. So 1.10 1.11, 2.10 2.11, 3.10 3.11 on each of these ports. So hope you are clear with this hub VNet, the architecture, and how exactly the FortiGate VM is going to have a 4 NIC for each, right? So this is the understanding of hub VNet, and the spoke VNet will be paired with the hub VNet. So whatever the traffic that it's sending out from the workload subnet, everything moves towards the hub VNet, and all the content will be inspected in this by this particular FortiGate VM, right? So how exactly the failover happens? So this is the interesting part, right? So I want you all to understand one thing before moving forward. So in this particular demo, we are going to make use of the Azure SDN Connector, right? So what exactly it does? So before that, I just wanted to make you guys understand more about the HA failover process, right? So this will, once you understand this workflow, then you will understand why we need this Azure SDN Connector in this picture, right? So consider that in the normal state, FortiGate VM1 is active, and you have your cluster public IP. This is the public facing IP, right? So which will be attached to the active, right? Active VM's port 2 NIC, because port 2 is the untrust, right? So 0.10, so it will be attached to this particular FortiGate VM01, and all the route tables, right, in the UDRs, I mean in the spoke VNets, everything will be pointing to the active VMs port 3, right, which is nothing but 172.1.1.10. So 172.1.1.10. And the traffic flow, how it looks like from the external. So from the internet, it will move via 52.10.10 and it moves towards 0.10 via the VM01 port 2, and it moves via the port 3, which is 172.1.1.10, and it reaches the workload subnet, right? So this is normally the traffic what we are following in terms of the normal state while the FortiGate VM01 is active. So what happens if this particular active VM01 goes down? So the failover process kickstarts. So the VM10 failure detected, right? So during the failover, what exactly happens? So this particular cluster public IP, right, which was earlier attached to the active, which is 0.10 of port 2, gets detached from this active VM and gets attached to this particular passive VM's FortiGate, the VM02. So this is what that is mentioned over here. So after failover, so the public IP, whatever that is attached, so it gets detached from the VM01 NIC and gets attached to the VM02's port 2 NIC, right? So that whatever the traffic, right, so it moves via, it starts moving via the passive FortiGate, right? And in this particular case, so this is a change that is happening in the untrust area. What about the trust area? So all our spoke VNets was earlier pointing to the active VMs, the private IP, the port 3 IP, right, which was 1.10. But since we had a failover situation, now the passive VM is carrying an IP address of 1.11. But your spoke VNets are still pointing to the active VM's port 3, right? So you have to update the UDRs. You have to update this route table to steer all the traffic via the passive VM, which is passive VM port 3, that is 1.11, right? So the destination, that is all the traffic should go via this next hop appliance, which is 1.11. So we have to change this UDR and the traffic flow, right? So it starts from cluster public IP, moves via the passive VM, and it reaches the workload subnet, right? So as you can understand, we are making two changes as part of this failover process, right? So what are those two things? So one, we are updating the Azure route table. Whatever the spoke VNets or whatever the private subnet that we have behind the FortiGate, we are just updating those route tables, right, to basically steer the traffic to either active or the passive, right? So this is one thing. And the another thing that is happening during the failover is that we are reassociating this particular cluster public IP, right, from this active to the other active. So what the secondary would become the active during the failover. So whoever is the active member, it gets attached to the particular NIC. So there are two things that we are performing, right, during the failover, right? So this particular update or this particular change will be handled using the Azure SDN Connector, right? So I want you guys to go ahead and read more about the Azure SDN Connector and how exactly it's going to interact with your Azure APIs, right? It basically authenticates using your service principal. So in the last the demo, I have shown you how to create a service principal, right? So we are going to just make use of the same service principal, because that particular service principal, the Terraform SP, is carrying a contributor role on top of your subscription. So we have the necessary, the tenant ID, subscription ID, client secret from the last the demo session, right? So during this particular failover, the particular FortiGate, it's going to connect to the external connector, which is the Azure SDN, to basically do these two things: to update the route table and to reassociate the particular cluster public IP to the active the VM NIC. So this basically requires a minimum role of network contributor, but our SP, which means our service principal, have already been given a contributor role, so which is more than enough to carry out this entire the Azure SDN based connectivity, right? So without any further ado, let's move ahead. So understanding this might be a little tricky, but I want you guys to stick throughout this entire the demo to understand the end-to-end deployment of this HA cluster architecture, right? So for the prerequisite, so just to quickly reiterate, you're supposed to have a active Azure subscription and you're supposed to configure the proper budgets, alerts, and everything in place for your Azure subscription, and the service principal with the appropriate RBAC role. So in the earlier session, we have created a service principal called the Terraform SP. So that Terraform SP will have the contributor role on top of your Azure subscription. And to deploy this entire FortiGate VM, so you are supposed to accept the FortiGate marketplace image terms, which I have explained in the last demo. And finally, since we are going to deploy the standard F2S family for your FortiGate VMs, so you have to raise your quota, because basically you will have only 10 vCPUs for allocated for this standard F2S family by default. So but we require 16 minimum 16 cores for this particular demo to work. So I request you to initiate the quota request to minimum of 16, or maximum you can keep it to 20, right? So just to quickly reiterate, so for the prerequisite, a service principal is already in place. You can create a service principal using this command once you are connected to the Azure CLI. So the Terraform SP is going to have the application ID, object ID, and the tenant ID. And similarly, you will also be able to generate the client keys as well, right? Secrets as well, right? And this particular Terraform SP which we have created, it's going to have the contributor role on top of your PG subscription, right? And similarly, you are supposed to accept the FortiGate's marketplace image terms. So this is the command. So once you run this command, so you will be accepting to those marketplace image terms, and you can validate it using this particular show command, right? So this is very pretty straightforward. And just to quickly let you know, guys, about what are all the things that we are going to discuss in the Terraform, the entire plan file. So once we review all the Terraform configuration file, so these are all the resources that are planned to add, or the changes that we are going to basically make. So we are going to create a new Linux virtual machine, which is going to be sitting in the workload subnet, and we are going to create a 9 network interfaces. As I said, we require 4 NICs for each FortiGate VM, which amounts to 8, and we need 1 NIC for the above Linux virtual machine, which is in the workload subnet, and the NSGs and the associations and security rules. We require the public IP address, right? And we require the resource group, and we require the UDS, route tables, storage account, subnets. So all these things are defined in the Terraform configuration file, which we will be reviewing it shortly, right? So as a total, we are going to deploy 48 the resources, or the 48 changes is what we are seeing for this particular Terraform deployment, right? And what exactly we are trying to cover in the FortiGate bootstrap configuration file. So let us just focus more on the Terraform configuration first, and then we can come back again on this bootstrap config file, right? So I have, as I said, so this is the URL what we are making use of. We are just getting down to the 7.x, and we are just doing the HA port on management, the deployment, right? So you can download all your Terraform configuration files from here, and let us just move ahead into the core the Terraform configuration file. Right, so to start off with, we'll just quickly understand the architecture what we have. So you have an active Terraform configuration file, and you have a passive Terraform configuration file. You have a network, you have a route, and you have a storage. You have your variables that are declared, and similarly you have the main.tf, which will carry the resource group creation and the marketplace agreement and the output part, and you have a bootstrap configuration file of both active as well as the passive, right? So you basically cannot find this particular file. This is the spoke vnet. So this I have just added for this particular demo to basically demonstrate you guys about how exactly this hub and spoke architecture will work, because basically once you download the Terraform configuration file for this HA the management deployment, you will only have the architecture of the hub vnet, right? So or the hub vnet, or the hub vnet, inside which you will have your private subnet. So this is what you will get. But to show you guys how exactly the spoke VNet gets paired with a hub VNet, and how exactly the traffic is steered from the spoke VNet to hub VNet. So I just went ahead and added one more Terraform configuration file where I thought of creating a spoke VNet resource inside which I'm just trying to create a subnet, and I'm just trying to create a route table, dedicated route table for that particular the subnet, and route the route table association, the network interface, a dedicated network interface for the test Linux VM, and the NSG association, security rules, and finally your Azure RM Linux virtual machine resource. So we are trying to create a test Linux VM1 behind the spoke VNet, right? So this is sitting in the spoke VNet entirely. So you can also create the same like you can have the similar file, you can customize your Terraform file based on this. And we are trying to create a peering connection between the hub and spoke. So this is for a bidirectional connectivity, so this is for hub to spoke one, and similarly we are doing it for spoke one to hub, right? So this is for VNet peering. So I've just created all these resources all by myself, so just for the demo purpose, right? So we'll just quickly start off with the main.tf. So the main.tf is having the Azure RM resource group creation, and we have the marketplace agreement, the part where you can accept the marketplace agreement from here using the Terraform the configuration file. And let us move into the next part where we will discuss about the storage. We are just having a random resource id, the same the storage account creation. And let us discuss about the variables what we have defined here. So the subscription id, client secret, tenant id, so everything you already know, so which all have been declared in the terraform.pf was file. And speaking about the size, right? So earlier we have deployed the smaller version, that is F4S V2, the smaller size, right? So we have deployed for a 4-core machine, but we require a minimum of 8 core with a 16 GB RAM, because what happens here is that we need a instance size that basically support 4 NICs, right? So the F4S V2 which we have deployed in the single NVA does not support 4 network interface card. So for which we have selected the same in that same F8S family we have FS family we have selected F8S V2 size to accommodate this 4 NIC, and it also supports for the accelerated networking as well, right? So we have, for the location we have chosen the central India. Then for the variable the custom is equal to false, because we are not using any custom image, because we are making use of the marketplace image. And let us move to the license type. We are using PG, the license format. If you bring your own license for both the devices, the license 1 and the license 2. Then we have the architecture. We are going to follow the 86, and so whether we are accepting the marketplace from here, so by default it's turned to false. And as I said, so if that particular the VM, right, so the F8 as V2, so it's if it is supporting the enhanced the accelerated networking, so you can enable that. And similarly we are just following for the publisher, the FGT offer, everything remains same. So the SKU gets mapped to this particular page model, and the version, the admin username and passwords are declared with the admin port. And we have a VNet CIDR which is defined for the entire the VNet, the hub VNet. And you have your public CIDR, you have your private CIDR, public subnet, private subnet, HA subnet, management subnet, and the individual active port subnet mask. So we have just created all the static APs as a variable, so you can collect all these details, you can map it to that particular diagram which I have shown it earlier. So for the active and the passive, we are just creating all those the private static IPs as a variable. And slowly moving ahead, we're just defining the port 1 gateway. Port 1, it's nothing but your the HA management subnet. So since it needs the internet connectivity, we are just moving or pushing all the traffic from this particular the port 1 to this particular 172.1.3.1, because Azure basically reserves the for IP address, right? So 1.3.1 it's going to be the gateway, and the port 2 similarly. So port 2 is the public facing untrust zone, so we're just pushing all the traffic towards this 1.0.1, and we are having our bootstrap file. So this is the active file, so the active file, and this is the passive file, right? And so these are all the things that I have added as an additional for my spoke vnet. So I'm just defining a separate spoke vnet, and the workload subnet inside it, the test linux VM username and password, and the IP, everything has been declared as a variable over here. So you can review this file, and you can customize as required, for your requirement, right? So you can modify it as you wish. And let us move into the active file, right? So in the active file, our major focus is on the marketplace image. So we are not making use of any custom image or the custom activate custom FortiGate VM. So we are going to make use of the marketplace image, right? So var.custom is equal to it's a conditional operator, so we are topping it the one because var.custom is set as false. And we are just launching it in this location, the resource group name, network interface ID. As you can see in the network interface ID, while creating this particular active the VM, so we are just defining 1 2 3 and then 4, right? So 4 NICs are getting attached to this particular active FortiGate VM. So this is what I have just told you guys. A single FortiGate VM requires a 4 network interface card, right? And similarly, we are just defining the primary network interface, which is our active port one, right? So our HA is HA management, the subnet. And similarly, we are defining the VM size, and the storage, image reference, the plan, and the SKU. Everything is pretty much straightforward. And so this is the OS profile or the custom data which we are passing it into our bootstrap file. So basically, we are trying to bootstrap our FortiGate to configure certain details or the certain parameters inside the FortiGate, within this particular Terraform deployment itself. So we are trying to supply the licenses, and we are trying to supply the port 1 IP, port 2 IP. Basically, you can review all these. So everything is part of the Terraform configuration file. So all these details, all these variables are passed as the value inside this particular the FortiGate bootstrap configuration file for each active as well as the passive, right? So I have just went ahead and added a couple more here, so just to have the spoke vnet in place, right? And similarly, you have the another configuration file for the passive. So we are not making use of custom image, so we'll focus on the passive FortiGate VM. So everything remains same. So instead of attaching the active network interfaces, we are just attaching the passive network interfaces for 1 2 and 3 4. So hope you understand the part where we are attaching the 4 NICs to the passive VM as well. And the image, the plan, and the other the storage and the data disk remain same. And even for the passive the FortiGate, we are supplying the same the custom data, and we are trying to bootstrap the passive FortiGate as well to configure all these supplying all these variables into the particular the configuration passive file. So it will receive all these variable file, and it will try to configure bootstrap and configure the passive FortiGate as well, right? So this is just an overview of both active as well as the passive Terraform configuration file. Let us move into the network part, where we will be creating we'll just quickly understand the skeleton. So we are creating a virtual network, which is the hub vnet or the inspection vnet. And we are creating a public subnet, a private subnet, a HA sync subnet, and a HA management subnet, the 4 subnets, right? So you can refer it from this diagram. So we are creating 1 2 3 4 subnets, right? So hope that is clear. And we are creating a cluster public IP, which is a public facing IP, and we are creating another public IP for active as well as the passive. So this is going to be purely for the management of the particular firewall. So active and passive is getting created. And we are creating the NSGs basically, and we are creating the security rules, then the network interface for active, port 1, port 2, port 3, and port 4. And we are creating the NSGs. So NSGs are done for all the port 1, 2, 3, and 4. And we are creating the passive network interfaces. So the skeleton, as you can understand, so you are creating 4 network interface, and the NSG associations again basically. So this is the skeleton, right? So we start with the network, the creation of all the subnets. You create all the public IPs. You create the NSGs and the rules, and you create a network interface. Followed by you create a NSG association. Similarly, you create all the four network interfaces for passive, and the NSG association for the particular the passive network interfaces which you have created, right? So this pretty much explains the entire skeleton of what is included in the network.tf file, right? So we have reviewed the active, we have reviewed the passive, and we have reviewed the network. So we will review the route as well. So this is just a small internal route table which will be attached, right, to your private subnet. So this is where we are attaching it. So this is where we are doing the route table association. So we are creating the route table, and we are adding a route where we are pushing all the traffic via this virtual appliance, and the virtual appliance IP is active.port 3. So as I said earlier, so this is the private subnet. All the traffic that is coming from this particular subnet will always move via the port 3 of the active VM, right? So similarly in the spoke VNet, so all the traffic will initially be pointing to the port 3 of the active VM, right? So this is the usual traffic. So while during the failover, we will try to update the UDR of both the private subnet as well as the spoke VNet, the workload subnet. So all the UDRs will be updated, and parallelly the cluster IP gets detached from this active VM, and it will get attached to the new active of VM02, right? So which we will discuss it quickly. So the variables declared, storage declared, the spoke minute I have reviewed, route is defined, the provider, which is very basic. So you are supposed to give the required power provider and the Azure RM specific features, whatever that you need. And the passive we have defined, and the output file, which is very pretty straightforward. You have your resource, we are printing resource group, cluster public IP, active management IP, passive, and the username and password. So now, so this is a small client.df file, so where I just commented it out because I don't want to deploy another the Linux machine into the private subnet, because I'm just trying to make you guys understand more about the connectivity of the spoke minute to hub minute, right? So you can comment this back out, right? You can remove this comment, and you can also have a Linux machine as part of this private subnet. So basically this particular entire it's creating a new network interface to this particular private subnet, and we are just they're just creating a Linux machine in this private subnet. So which means they are creating a VM inside this subnet. Since I don't want to explain more about putting this machine in this private subnet and pushing the traffic to the FortiGate, I just wanted to explain you guys how workload which is sitting outside of the hub VNet, which is sitting in spoke VNet, how it is supposed to push the traffic towards the FortiGate. So basically that is why I have included the spoke VNet.tf file, which we have discussed earlier, right? So let us just quickly discuss about the bootstrap configuration file, right? So this is pretty straightforward, and probably you can have the system global configuration, the host name, admin port, time zone, and everything. We are trying to configure the system interfaces, right? So the port 1 is the management port, HA management, and port 2 is the untrust, the public facing. Port 3 is the trust, the private facing, and the port 4, which is going to be the HA sync between the two appliances. And we are trying to create a HA configuration. So we are configuring the system HA in the name of Azure HA. And the mode is active passive, the HP dev, and then the session pickup enable, the heartbeat interval, the heartbeat loss threshold, every the default setting that you can, that whatever that is mentioned here on this particular seconds, you can keep it same. And for the HA management interface, you are supposed to mention the port 1 as the interface, which is the HA management interface, and you are supposed to set the management gateway, right? So management gateway IP, and so these are, you are supposed to set the priority, the password, all the orchestration parameters as part of this HA configuration, right? And you are also supposed to set the passive peer IP. So passive peer IP is the passive address of this particular the passive FortiGate, right? So then the passive VM. And we are trying to configure the static route, so for the default traffic, and for the subnets which are sitting behind the FortiGate, so which is the 172.2.1.0, which is the subnet that is there in the spoke. right? So we are just creating the static route, and we are trying to have a DNAT to the backend machine, so that the ingress for this particular active, right, which is coming from 172.1.0.10, which is nothing but this 172.0.1.0.10. So we are just hitting this FortiGate VM1 port 2, and it gets DNATed to the particular workload subnet. So we'll try to SSH into this test Linux VM using this cluster public IP, right? So this is a DNAT configuration, and the firewall policy I have added it over here. See, basically you will not be able to find all these details in the configuration, the bootstrap configuration file once you download it from the Terraform registry, I mean from the GitHub registry. But just to showcase you guys the entire the traffic flow, I have just added all as part of this bootstrap itself. Then we are just adding a LAN to WAN policy from the port 3 to port 2, and the DNAT policy from the port 2 to port 3, right? So from the outbound to inbound, and the inbound to outbound. So that is also added. So this is where the entire the configuration gets tricky, where we are trying to configure an external connector, right? So the Azure SDN connector, right? So we are trying to do the HA status enable. We are just sharing the tenant ID, subscription ID, client ID, and client secret, and the resource group name. So these details are mandatory for a FortiGate to communicate with the Azure ARM APIs, right? So FortiGate will assume the contributor role which is given on for this particular service principal, right? And it will start modifying two things. So one, it will start moving the public IP, the cluster public IP address, to the active VMs port to NIC, right? So this is one part. So it will modify the NIC of the active port 2. It will configure the IP to set the public IP as the cluster public IP, and it is modifying the UDR, right? So this particular using this SDN connector, our FortiGate will go ahead and modify the UDR of the this particular the route table. So our route table name is route name, and we are modifying the route where we are just modifying the next hop IP address, right? So basically what we are trying to do, we are trying to achieve two things as part of this HA failover. So upon failover, the public IP, whatever the cluster public IP attached to the active VM, is supposed to be detached and reconnected to the passive VM 02. And similarly, once that is done, we have to update all the spoke VNet UDRs to point to the new active VM, which is the VM 02. So the SDN connectors are configured in a way. So we are doing two things. One, updating the NIC, and updating the UDR, right? So this is the route table or the route which is there in the private subnet, and I have added it over here for the spoke VNet as well. So this is this configuration, the bootstrap configuration file for the active, and similarly we have the same set of configuration for the passive as well. So we have the system global, and we have the interface configuration, and we have the HA configuration. So everything remains same. And so here we are setting the active peer IP, because this is passive what we are seeing right now, and we are having the static route configuration. We are doing the DNAT, and I want you to note this particular ingress. We'll discuss it. And now you have the same set of firewall policies, the LAN to WAN, the DNAT policy, and the same SDN connector for your passive as well. So we are supplying all these tenant details to the resource group. Then you have your NIC modification. Then you have your route table modification, right? So the configuration file or the bootstrap file might be a little tricky for you to understand, but I need you guys to just focus on it. Just slowly try to understand and observe. Probably try to get more hands-on to understand how exactly this particular HA behavior it's going to work, right? So let us just move ahead. We'll straight away start to deploy, right? So just before getting this deployment started, so we'll quickly reiterate all these things. So prerequisites covered, the Terraform plan is covered. So the whatever that we have discussed in the bootstrap configuration file, so I have mentioned it over here for your reference. So to start off with, we are configuring all the system configuration, then the interface configuration, followed by the HA cluster configuration, then static root definitions, DNAT VIP creations, the firewall policy for LAN to WAN and the DNAT, and then we are trying to configure the SDN connector. So where we'll be making use of the mapping of the tenant ID subscription and everything, right? And we are doing two automations based on this. I mean, using this SDN connector. So we are trying to do the public IP association from the old active to the new active. Then we are doing the route table updation and the UDR updation, right? So as a whole, the FortiGate bootstrap configuration file, we are going to make a 33 changes, right? So this is at a high level. I just wanted you guys to know. Then to move forward, we are going to initiate the deployment. So let us start with Terraform init. So whenever you start a deployment, it is mandatory to initialize that particular directory. Then I need you guys to run quickly the Terraform validate as well to check for any syntax error if you have got in the Terraform configuration file. Once that is clear, then we'll start or move ahead with the Terraform plan hyphen out. Probably we can name TF plan 12, and we just will make every input as false. We're not giving any, and probably we have to. I'm just supplying the var file because basically we have the terraform.tf also, right? So terraform.tf we have supplied. So right now the plan is running. So as you can see, it is going to help us with the plan file. So yep, so we have finally got the entire plan, what are all the changes that it's going to make. So I need you guys to review all these additions, right? So what all it's going to create one by one. So that is why I thought of consolidate everything into a tabular column. So this particular the 48 plan or the 48 to add, right? So that is what I have just given it in this particular the tabular column. So you can cross check it whether you already have, I mean, I'm getting around whether you are getting around this 48 resources or not. Since I'm creating the spoke vnet also, so there will be an addition of other resources like spoke vnet, subnet, and the test linux vms and the nix. So if you guys are only deploying as per the Terraform configuration file that you have downloaded from the registry, then you might not get a 48. So you have to validate it manually for your the file, your Terraform configuration file. So now just let us move ahead and deploy this. So the deployment, it's going to start. We'll wait for a couple of minutes because we have to create two FortiGate VMs, the subnets, and the backend test Linux VM as well, right? And the spoke VNet, it's going to get peered with this particular hub VNet, onto this particular Terraform deployment itself, right? So we'll wait and then we'll observe the individual resource creation. So as you can see, all the VNet, the route table, the subnets, everything, it started creating. Yep, the network interface is creating. The creation is getting completed, and yep, we are moving ahead with the peering. So peering to hub to spoke one, the peering to spoke one to hub. So that is now it's creating. Yep. So the NSG's association is happening in the backend. So this is pretty cool actually. So basically, if you guys learn more about the Terraform deployment, so which basically orchestrates everything, and it deploys everything, like does this automation on behalf of you, right? So basically you need to learn this Terraform somehow to automate everything, to automate this entire deployment. So we basically don't want to pick and choose, drag and drop, and configure every configuration from the GUI, so because that is not going to be an interesting way when we have the production grade deployment. So yep, so we are just seeing a progression. So we are seeing the active FortiGate VM creation. Yep, and there are some other energies which are getting parallelly created. So if you are deploying it for the first time, this deployment might take under 15 to 20 minutes. But since I have deployed it a couple of times and went ahead with the demo, it is just creating very quickly for me. So you might face a little delay because you would have accepted the marketplace terms newly, and you would have created a service principal newly. So you might expect some sort of a delay in this entire the Terraform deployment. So almost 2 minutes gone, and still we are seeing the active FortiGate VM creation. So the passive VM is not even deployed so far, right? So we'll wait. So you have the TF state file which is created already, which is keeping the reference for all the resources that is getting created. And similarly you have your the .terraform folder while you initialized, and you have your log and the TF state log file and everything which is created. All right. So actually, I don't want to skip this part because I need you guys to look into this entire deployment. I don't want to fast forward this entire the Terraform apply. So understanding this Azure SDN part might be a little tricky once you start with the initial deployment. But once you get enough understanding from the architectural diagrams, from the way how this entire SDN works, then it will be pretty interesting for you to move forward, right? So yep. So for the active FortiGate VM, the creation is complete after 2 minutes and 54 seconds. Yes, that is a good sign. And yep. So we are moving ahead with the passive FortiGate VM creation. So again, this is a good sign. So again, we have to wait another 1 or 2 minutes for this entire the passive FortiGate VM creation as well. So you might be actually wondering that, right? So in our architectural diagram, so we have not introduced any component of BGP, right? So we haven't even started discussing BGP and how exactly we are going to integrate the dynamic routing into this entire the hub and spoke architecture. So we haven't connected the local on premises to the Azure. So we haven't started doing the BGP peering and prefix sharing, and the entire the dynamic routing part we haven't covered in this active passive deployment. So just before doing this BGP and making the hub and spoke setup with the Azure route server and the BGP configuration, so I just wanted to make you guys understand how exactly this active passive VM is deployed in Azure, and what are all basically the method that we have got so far, and what is the HA failover process that will basically help you to understand how HA happens in Azure for this particular active and passive VM, right? So it's still creating the passive FortiGate VM. So almost 2 minutes and 20 seconds elapsed. We'll wait for another couple of minutes. Probably can see some green signal for the passive FortiGate VM as well. Yep. So passive is taking a little bit of a, yep, okay. We got a green signal, so we the passive FortiGate VM creation is complete after 2 minutes and 54 seconds. And yes, so the final creation of the Tesla Next VM, the Tesla Next VM creation is also completed. So the entire the Terraform apply got success, and almost 48 resources are added, and we got the output which is displayed over here. So you got the active management public IP, you have got your cluster public IP, which is the public facing. The 20.197.62.224 is the public ingress, so this cluster public IP, right? So the what is then this particular active management of public IP is that, so we are attaching it to this particular FortiGate VM1 for the HA management, right? So this is one and this is one. So we are getting a two public IP address. So this is one URL and this is the other URL. So the admin's port is set as 8443 for individual VMs. And we have got the password, the resource group, and the username. So before moving further with logging into the active FortiGate VM and the passive VM, so let us just review what are all the resources that are added, right, and their existing state. So we'll direct ourselves to the Azure Management Console. We'll go into the resource group, so you can find the resource group which is created as part of this Terraform configuration. And as you can see, there are like a lot of resources that are created, right, as part of this Terraform deployment. You have the data disk and the OS disk, and you have multiple network interface card which are created as part of this deployment. So as I said, for each FortiGate VM you have 4 NIC, so the port 1, port 2, port 3, port 4, and for the passive you have your port 1, port 2, port 2, port 3, port 4, right? So there is a separate NIC for the Tesla Next VM, and the NSGs, so for the public facing, the private facing, and for your workload subnet which is sitting in the spoke VNet. And you have your active management public IP, the cluster IP, as well as the passive management IP, which we have seen in the output. And you have two route table, one being the internal route table which is attached to the private subnet. So this private subnet is attached to the internal route table, and this workload subnet is attached to the spoke route table, right? So spoke route 1 is the route table for the spoke VNet, I mean spoke VNet's workload subnet. And you have your storage account, and you have your active FortiGate VM, and you have your passive FortiGate VM, and you have your Tesla Next VM, the network, the two virtual networks. So one being the hub VNet or the inspection VNet, and another being the spoke VNet. So let us inspect the active FortiGate. So the active FortiGate, it's running FortiOS 7.6.6, and the size, it's as I have told you. So we require a minimum of 8 vCPUs, and we also need a support for the 4 NICs as well. So we have went with the F8 V2. As you can see, since this is active FortiGate, so the primary NIC public IP, So currently the public IP, which is the 41.122, so that is the cluster public IP. So the cluster public IP, oh, I'm sorry. So this is just giving me the active management public IP, correct? So this is giving me the port 1 HA management IP, and similarly you can also find the private IP which is associated, and the other associated public IPs as well. We'll come back again to this. So you have the 41.22 as well as the 62. The 224, right? So which both are attached to active port 1 and port 2, right? And you have the private IP, which is part of this 3.10, and pretty much the source detail, image details, and everything that you can find it over here, right? So similarly you have the same for passive as well. So let us review the passive FortiGate file. So it is again running 7.6.6, the same configuration, and you have the what is that, the HA management subnet public IP, right? And you have the private IP which is associated, and the source and image details. Pretty much everything is clear for the passive as well, right? So from the this particular architecture, right? So this particular cluster IP, whatever that we are seeing right here, right? So the cluster public IP, initially it gets attached to the port to untrust of active VM 01, right? So which means we have to go ahead and inspect the port 2 of active. So we'll go here, we'll have to go to the active port to NIC. So we'll enter here. So here you can find the public IP address, which is 62.224, the cluster public IP address. It's attached to this particular active port 2. So this is the start situation, this is the normal state. While the FortiGate VM 01 is active, we have the cluster public IP which is attached to the port 1 NIC of active VM 01, which is nothing but your active port 2 NIC, right? So this is clear, and this active port 2 is attached to the active FortiGate, and it's carrying the private energies and everything. So this is pretty straightforward. So now that we are clear, and I just also want to you guys to review the passive port 2, because this is where the public IP is going to get reattached once the HA failover kickstarts. So right now we are not seeing any public IP address, the cluster public IP address, which is attached to this passive port 2, which is nothing but this port, right? So we are not having any cluster public IP address attached to this particular passive VM, because right now the active VM, which is VM 01, the traffic is entirely handled by the active VM, right? So we'll try to quickly inspect the firewall configuration, whether that is properly done or not. So we'll try to open the active VM first. Yes, I'm getting the GUI page. So let us log in first. So we have to quickly validate the bootstrap file, right? So whatever the bootstrap configuration that we have supplied, whether that is covered or not, configured or not, we will just, maybe we can do this later, right? So as you can see, this is the FortiGate's the active passive SDN cluster, which is active as this is the active VM, and we are having the HAS primary, and the status is synchronized, right? So we'll review that quickly. So for the network, we'll start with the network interface. So you have a 1, 2, 3, 4 network interfaces configured. So for each of these purpose, so one being in the untrust, and the other being in the trust, and the other two are for the HA management and the HA sync, right? So all the respective the static IP address that we have given it in the variable file all got added. So 0.10, 1.10, 2.10, 3.10. Yes, pretty much everything is clear. Let us move into the static route. So in static route, so the default route, it's pointing to 172.1.0.1, which is nothing but the public facing the subnets gateway IP. So which is nothing but 172.1.0.1. So that is the IP address reserved by Azure for the gateway. Yes, and it's moving via untrust port. And For the subnets that are behind the FortiGate, we are just creating one static route entry for that. So that is also created. Let us move into the policies. Let us review the policies quickly. So yes, we have got two policies, one being the LAN to WAN and the other being the DNAT. So the LAN to WAN is already alive, and you have the DNAT. So the DNAT is again the virtual IP is already created. So we have the external IP address, which is 1.0.10, and it is mapped to 2.1.10, which is nothing but this particular backend machine. So once you hit the cluster public IP, we can directly SSH into the test Linux VM. So that is what we are trying to achieve. So we are going to take this path towards the FortiGate VM1, moving towards the private subnet and to the peering, and we are going to hit the spoke VNet workload subnet VM. Right. So basically that is the DNAT configuration which we have configured it over here, and basically we have the mapped external port as 1.0.10. So 1.0.10 is the active port to untrust IP. So that is also clear, and let us move into the VIP part. Yes, so VIP is again created with the 0.10 with the 1.10. So let us now move into the next step. So we haven't configured any security profiles as of now. So there is no VPN, user authentication, Wi-Fi controller systems, and probably in the systems we have configured some settings. So for the time zone, the other admin port and everything. So yes, those things are in place. Yes, obviously the HA part, the high availability part. So we have got the active as well as the passive VM, which is participating in HA cluster, and the serial numbers are given here, and the role, the primary and the secondary, and the system of time, the sessions between them. So you will get the primary as well as the secondary status, the heartbeat status as well, right? So everything is again pretty clear over here. So which means your HA is live right now. So you can see the HA is working, and let us move ahead into the security fabric, where we'll understand the physical topology if we can find any. So you have your the active as well as your passive, which is acting in this HA cluster. So that is also pretty clear. Okay, so let us just move into the external connector. Yep, great. So here you can find the external connector, the Azure SDN connector. So this is the Azure connector, where we have configured the directory ID, app ID, subscription ID, resource group, and everything. So the status is up, which means our external SDN connector is it's live and it's working now. So let us just move forward, and we can quickly evaluate the passive firewall as well. So this is the passive firewalls, the management IP. Let me open that so that you can understand. So this is active, this is passive. So let us just quickly log into this INET. Okay, I'm sorry, I thought I forgot the password, so we'll skip this. Great. So you now have got the passive VMs access. So this is acting as a secondary in the HA cluster, and the network interface is clear. Your static route is clear, and moving ahead to the firewall policy. Right. So that is also clear, and VIP. So at this point of time, you're supposed to come up with a one clarification that we have defined for 0.11, but we are getting the 0.10. So this is where this architecture is getting interesting, right? So I will explain it in a moment. Then moving ahead to the system settings and everything. So basically the HA in the whatever the secondary that is participating in the HA cluster, the database from the primary, it gets synchronized with the passive. So basically everything is replicated. So we'll evaluate the external connector as well. So even passive carries the same the configuration. So active is here and the passive is here, right? So now that we are clear with the active passive configuration, right? So we'll try to quickly, SSH into the backend machine, and we'll observe if that particular traffic is moving or not, right? So we'll get into the terminal. Probably we'll try to initiate the SSH session first. So our username is Azure user, because that is the username that we have defined for back in test Linux machine. So I am supposed to hit the cluster public IP. So Azure user at this particular 62.224. So that is the cluster public IP, right? So I'm not hitting the active management or the passive management IP, because those two are for the management purpose. But for the actual traffic, I'm supposed to initiate the traffic to this particular cluster public IP. Great. I'm getting the all right, let me enter the password. Let's see if I'm able to log in. Great. So as you can see, I have successfully denated into my test Linux VM1. So I have just initiated the SSH session using this cluster public IP address, which is 62.224, which is the cluster public IP. So I'm sitting in from the outside of Azure. So I'm trying to initiate a SSH, and I have successfully landed into my test Linux VM. So that is what you are seeing right now. So I'm inside the workload VM, right? So let me try to ping towards the whether the VM is having the internet traffic or not. Yes. So hopefully that VM is right now moving towards internet, and how it is moving forward. So that is the interesting part, right? So we'll try to just try to understand what is the public facing outbound, right? So as you can see, I'm just trying to curl this URL, and I'm trying to get I'm getting 62.224, which is nothing but our cluster public IP address. So which means my traffic, so I have denatted successfully into the workload subnet, and this particular from this workload subnet, I'm trying to initiate some internet traffic, and that traffic is moving towards the VNet peering, and it's moving via the FortiGate, and it's moving via the cluster public IP, which is nothing but my the 62.224, which means my north south traffic, it's successfully working, and my machine is having the internet access. Now I can configure whatever the policies that I want in my FortiGate to restrict my the outbound the traffic, right? So and basically you can start doing the north south inspection, or probably do the east west kind of a traffic steering as well. So this is at a high level what I just wanted to show you guys. But to the objective of this particular entire demo is to understand how exactly the HA happens, right? So we have to initiate a failover. So for that, we'll just get into this particular the console. So we are going to manually initiate a failover by setting the passive as the new active VM. So for that, so this is just I wanted to show you guys. So we have verified that we have the SDN connectors in place, and whether you are getting the TCP connection or probably the particular the DNAT, right? So if it is working or not, you can run this command and you can check it to initiate the HA failover. So this is the interesting part. So we have to first understand whether the HAs are in place, whether those two devices are synchronized. So from the GUI, we understand that this particular the both the active and the passive is participating well in the HA cluster. But from the CLI, so let us just understand from the CLI perspective. So get system HA status, right? So yep. So we'll run this. So as you can see, it is throwing me some data. So it is in the cluster. We are having the primary because it's given the override priority larger than the peer member. So which is nothing but this serial number, this guy. And you have the HSync port, and you have the peer IP, the unicast peer IP what is given. So that is also mentioned over here. And the heartbeat area and the number of members in the cluster, the SDN active, which is setting in the cluster index as 1. So we're just going to switch this particular the primary to the secondary. So right now I'm in the connected to the active FortiGate. So I'm just going to do the failover using this particular command. So we are just going to initiate the failover. So before that, I just wanted to show you guys one thing. So since I have already connected to this particular the test Linux VM, let me do the ping, right? So that you will understand how exactly the failover works, because I don't want to do the count. Let me try to do it in a continuous ping, right? So it is already pinging, right? So let me do the failover now. Execute HA failover set 1, right? So I'm just setting 1. So it is telling me that this command will trigger an HA failover. It is for an internal testing purpose, obviously. Yes, I've just given yes. So great. Now that I have given yes, so it is the HA failover is it's happening right now. How I can verify? Either I can move into the GUI and validate, or I can just do again the get system HA status, right? So you can just enter this command. Yep. So here you can see the primary selected using, because we have just went ahead and initiated a failover flag, right? So we have just set the flag on the peer to make the peer member as the primary, right? So it is just now doing the failover. So let me just close this. Let us just move into the system HA. We'll refresh it. All right. So now you can see the active, right? So active, the FortiGate VM became the secondary, while your passive, right, which basically became the primary. So basically the HA happened, right? So the failover happened. As you can see right now from this particular VM, the console, my DNAT connection, right, it got interrupted. I'm not getting any reply because basically my DNAT session or the SSH, the DNAT traffic or the SSH session got interrupted because I'm not getting any reply back, right? So this is the expected behavior. But yep, so we just got the client disconnect with the broken pipe connection, right? So which means that my DNAT session, which was earlier served by the active FortiGate, got dropped, and right now I just got the error which is saying the broken pipe. So at this point now I believe you are clear that the failover happened, right? But let me try to initiate the traffic once again, because I just have the passive also, right? Passive VM which is sitting here, which is right now is supposed to take care of the traffic, my DNAT traffic, right? So this is the passive VM which is right now. Let me refresh that. Yep. So it is just taking some time. So the passive is again primary and the active is again secondary, right? So now that the passive got the primary role, let me just try to initiate the SSH once again, right? So I'm getting an error stating that so the remote host identification has changed. See, I'm getting a please contact your system administrator, because whatever the key that what we are giving right now, it is telling me that someone could be eavesdropping on you right now. Supposedly it is like a man in the middle attack, MIM attack, right? So what happens here is that, so the first SSH session that I have initiated, right, so that is to the active FortiGate VM 1, right? So basically what happens here is that when the HA failover happened, I try to initiate another DNAT, the SSH traffic. So it is saying that someone is eavesdropping on you. It might be some sort of a security compromise, and it is asking me to revalidate it or probably contacted the system administrator. But the problem here is that, right, so since this is a host key verification file, so this is one part. But what I wanted to show you guys here is that, see, in the Terraform configuration file, or probably in the Bootstrap configuration file, so let me show you. So this is the active file and this is the passive file. Let me open it parallelly. Okay, so for the DNAT, right? So let me move into the DNAT part. Yep. So this is the DNAT and this is the DNAT for the active and the passive, right? So while doing the bootstrap file, here I have given the external IP as 172.1.0.10, and for the passive I have mentioned it as 172.1.0.11, right? So this is the bootstrap configuration that I have mentioned. But if I just move into the FortiGate, right? So let me show you the virtual IP area of both the FortiGate. Okay, so I'm moving ahead to both the VIP of active and VIP of passive, right? So from this particular configuration understanding, so the active FortiGate, it's supposed to have the external IP mapped as 172.1.0.10, and the passive FortiGate is supposed to have 172.1.0.11. But let me validate that. Okay, in the active I'm having the external IP address for the DNAT, which is mapped at 172.1.0.10, which is correct, which is mapped to 172.2.1.10, that is also correct. But when we talk about the passive, okay, passive again, it's again having the 172.1.0.10 instead of 172.1.0.11. So this is one thing that you have to notice, right? So what happened here is that once you bring the passive, right? So once the passive, the FortiGate VM got bootstrapped, it might be initially configured with 172.1.0.11 as per our configuration file, the bootstrap configuration file. But once you bring this the passive into the HA cluster, all the databases will be, I mean, all the objects, everything gets synchronized to the passive. So what happens basically here is that, see, in this particular architecture, whatever that you have created in the active, it gets again synchronized, the object gets synchronized into the same value, right? So you basically cannot have a different value set here, I mean different object value set for the external IP and different object value set for this particular passive FortiGate VM. So which basically tells me that, right, so if I am supposed to initiate a SSH session after the failover, I'm still directing myself to the FortiGate active VM1. Right now it is not active at all, right? Because if I could see the passive VM, which is right now the active one, it is receiving the DNAT traffic from 0.10, while 0.10 is the active VM's IP. But my passive VM's IP is supposed to be 0.11, so that is why I have mentioned it as 0.11 in the configuration file. But since we have brought this passive VM into the HA cluster, this particular object got synchronized here, right? So this is some sort of a limitation for me here. So what I'm supposed to do, I'm supposed to modify it manually here. So just for the demo purpose, I'm just modifying it here. So just hold me with it. Okay, we just modified 172.1.0.11, which is nothing but I'm trying to receive my SSH traffic onto this particular FortiGate VM, which is on 172.1.0.11, and I'm trying to push it to the spoke VNet. So as I have told you, so once we do the failover, two things happen. So one, the UDRs will get updated, we'll have to validate that, and whether my cluster public IP, which was earlier associated to the active VM1, whether it got dissociated, detached and attached to the passive VM. So let's verify that. So for that, we have to move into our Terraform, the resource group. So this is the active port 2. Earlier our the cluster public IP was attached. As you can see, our public IP address got detached, so there is no public IP address at all. So where is that public IP address then? So let us move into the passive port. Great. So now you can find the public IP address, the cluster public IP address, which is dynamically attached to this passive port via the Azure SDN, right? So our FortiGate basically connected with the Azure ARM APIs to basically move this particular cluster public IP from the active port 2 to the passive port 2. So this is where SDN or the external connectors come into picture to basically move the resources, right? So basically to modify the resources that are sitting in Azure to basically do the HA the flow, right? The HA failover. So now that is clear. So we have migrated the entire the public IP cluster public IP address from active port 2 to the passive port 2. Let us now quickly inspect the spoke VNet UDR, because we understood that the association of the public IP is completed. Next, we will evaluate the route table updation. So we'll move into the Tesla Next VM1, and probably in the IP configuration, you can see that we have a 172.2.1.10, which is the static IP address, assigned to this, and it's sitting in the workload subnet. So let me scroll down and I can see the effective route. All right. So here I should see that this particular test Linux VM1 should point to 172.1.1.11, which is the passive IP address, the port 3 passive IP address. So let us just verify. Right, so this is my UDR. So all the traffic towards the virtual appliance it should move via 172.1.1.11. Great. So the UDRs are updated. So I might not have shown you the UDR earlier, because earlier it was pointing to 172.1.1.10, right? But how I can validate, here you can see in the spoke VNet. So this is my spoke VNet. So in the spoke VNet, I have just earlier had the UDR which is pointed to active VM. So right now it is pointing to 172.1.1.1, which means it is now pointing to passive. So once once the failover happened, it automatically the particular UDR got updated. So now that you are clear, two things happened during the failover, right? All right. So now that you are clear with how this entire failover happened and how the backend update of the cluster public IP as well as the spoke VNet UDR updation happened. So let me just go ahead and quickly try to initiate one more the Azure session. So it is asking me for a password right now. So let me just enter the password. All right, so as you can see, I'm able to DNAT into my machine, so which right now the let me show you, get into the HA part. So right now the active is acting as the secondary and my passive is my primary. So this is my passive, this is my primary, right? So basically, yes, so my passive is my primary, right? So we have successfully SSH'd into this machine. So let me just try to ping right now. So 8.8.8.8, let me put a count to 4, right? So as you can see, I'm able to ping, and probably I can do curl as well, right? So just to quickly verify. Awesome. So I'm getting 62.224. All right. So 62.224, which is nothing but my what is this cluster public IP address, right? So basically, what happened? So I have executed the failover. The traffic got moved to passive, but the problem being here is that, so I had a different ingress here. The once the passive got in touch with the active VM, formed a HA cluster. It just the whatever the data and the databases, the objects are synchronized with passive, which again went ahead and overwritten, right, our port 2 or the external facing IP of our DNAT access. And once you do this demo, right, so once you go through all this, you might see some internet drop or the intermittent drop in terms of this ping once you do the failover, right? So what happens here is that there is a open limitation. There is an open limitation with this entire architecture, which I'll walk you through right now, right? So you have validated the connector, you have verified, you have initiated the failover and verified it. You have initiated a SSH session to the backend test Linux VM. So if you are getting an error as this, you can try to generate a new key using this particular cluster public IP, and you can use this command to again initiate a SSH session, right? So so basically we have came till this part. We have tried to verify it, whether the traffic is moving a FortiGate and the public IP in which it's moving out. So this we have validated. But so the possible, right, so what is the limitation of this architecture that we are discussing right now, right? So there is a behavior, right? So we are doing the normal operation. So the public IP is attached to the FortiGate, the port 2 of the FortiGate, the active. So the HA state changes because we initiated a failover. The public IP got reassociated to the new the passive VM, right? So the UDRs again are updated in the backend via the SDN connector. So that also happened. But there might be a chance there is a convergence period, right? So your outbound SNAT might not work immediately. So this is a very stringent limitation that I have seen, because this convergence or the outbound SNAT, right, so it takes some time. Probably in my case it took me like probably 2 to 5 minutes of a time, right? So this convergence time, which is some sort of a downtime for us, because there might be hundreds of VMs sitting behind my FortiGate, and there might be hundreds of VMs which might be initiating the API request towards outbound internet. So if my FortiGate does this failover, then there will be a brief time of this particular outbound SNAT issue, right? So this particular the what is this tabular column will help you understand it clearly. So immediately after failover, your failover gets successful, your public IP gets reassociated, your UDR gets updated, even your DNAT will work, but your outbound internet from even from the FortiGate will not work. Even from the backend it will not work, because there is a convergence, there is a time. The outbound SNAT mapping will take some time, so you have to wait another 2 to 5 minutes of a time to get it actually working, right? So this is a pure cut limitation with this particular HA failover architecture, what we are seeing right now or what we are discussing. So the root cause, what we are quickly highlighting here is that, so Azure specifically converge, right? So there converge this entire the public IP reassociation between NICs in this particular floating public IP architecture, right? So there is going to be some sort of a limitation with our outbound SNAT and the internet egress, right? It will take some time. But for us, since we were discussing it for a pretty good time, so there is I couldn't able to show you guys. But if you are moving ahead with this demo, you will definitely see after a failover, you will not be able to reach the internet from the public, I mean from the test Linux VM. So you'll have to wait some time. You'll have to probably wait for a minimum of 180 seconds or more, and then you have to try initiating the public internet traffic, right? So this is a pure limitation what we observe. So in order to overcome this limitation, so we are moving ahead or evolving ourselves to the next set of a deployment. So this is our next demonstration, where the same active and the passive VM is going to be there. However, we are going to make use of the both the floating public IP as well as our floating private IP. So this is going to entirely put a seamless experience for us, which we'll be discussing it in the next demonstration, right? So I believe you are aware about the entire the HA, the active passive failover by now. So I want you guys to go ahead with this hands-on the demo deployment. You can try it, you can showcase it to your customer. Probably once you get a hands-on on this, we can move into the next step of understanding how exactly having a public float as well as the private float it's going to work and contribute moving forward, right? And slowly we'll also try to introduce BGP into the picture. We'll talk more about the dynamic routing. We'll introduce the on-premises firewall. We'll do the route exchange between these the providers, and we'll try to simulate the actual enterprise grade setup with the hub and spoke architecture, and we'll try to steer the north-south as well as the east-west traffic moving forward, right? So hope you like this video and demo. Stay tuned, and thank you for watching.